For the last century, we have operated under a comforting assumption. By mapping the rules of quantum mechanics and general relativity, we believed we were finally reading the instruction manual of reality. We saw a universe that behaved predictably, operating like a giant cosmic clockwork. That certainty was challenged in 1998. Two independent teams of astronomers set out to measure how quickly gravity was slowing down the expansion of the universe after the Big Bang. Instead, their measurements of distant supernovae showed that the expansion was accelerating. Something was actively pushing the cosmos apart. This chart shows the total energy makeup of reality as we currently understand it. Every star, planet, and atom you have ever touched fits into this tiny 5% sliver of ordinary matter. Another 27% is dark matter. The remaining 68% is dark energy, the invisible force driving this cosmic acceleration. Here is the conflict. When physicists use quantum mechanics to calculate how dense this energy should be, the result is larger than our actual observations by a factor of 10 to the power of 120. This disagreement between our two most successful theories, quantum mechanics and general relativity, is widely considered the least accurate prediction in the history of science. When the gap between theory and observation is this vast, it indicates that our framework for understanding reality is missing its most significant component. Our current physics is unable to account for the primary force shaping the universe, leaving the door open for phenomena that operate by rules we have yet to discover. According to the rules of planetary formation, planets require a star. They are expected to coalesce from the disk of gas and dust orbiting a young sun, relying on its gravity to pull them together and its heat to define their composition. In 2023, the James Webb Space Telescope turned its sensors toward the Orion Nebula. Astronomers were looking for a standard stellar nursery, but the infrared data revealed hundreds of objects that contradicted our existing laws of planetary birth. Scattered across the nebula were approximately 540 bodies, drifting without any host star. Many of these Jupiter-sized objects were traveling in pairs, designated Jupiter Mass Binary Objects, or JUMBOs. They emit no visible light, and according to our current models, have no reason to exist in such numbers. Theoretical models suggest these wanderers might not be dead rocks. A rogue planet of sufficient size can generate internal heat through radioactive decay. With enough pressure and time, they could maintain massive liquid water oceans beneath thick shells of ice, thriving in the dark without a sun. Current estimates suggest there are billions of these rogue planets moving through the Milky Way. We are now forced to reconcile a galaxy teeming with worlds that our current theories of planetary formation are unable to explain. The universe does not gently create the elements that make up our world. It generates them through events of incomprehensible violence. When two ultra-dense neutron stars spiral into one another, they trigger a kilonova. This is a transient explosion roughly 1,000 times brighter than a standard stellar death, shaking the fabric of space-time across millions of light-years. The intense energy of this collision allows atomic nuclei to absorb neutrons at blistering speeds, a process that creates heavy elements. Every gold ring, every gram of platinum, and every atom of uranium on Earth was forged in a catastrophe like this. Sometimes a star's collapse produces a magnetar. These pack the mass of a sun into a sphere the size of a city, but with a magnetic field up to 1 quadrillion times stronger than Earth's. It is a force so localized and intense that it physically warps the shape of atoms into thin cylinders. Magnetars are highly unstable. When their dense crusts fracture in a starquake, they release catastrophic bursts of radiation. In 2004, a pulse from a magnetar 50,000 light-years away struck our atmosphere. In a fraction of a second, it released more energy than our sun emits in 250,000 years, blinding satellites and ionizing Earth's upper air. There are hundreds of these objects currently dormant in our galaxy. We have no way to predict when a crust will fracture, and no defense if one happens to aim its radiation directly at Earth. In 2012, physicists at CERN confirmed the existence of the Higgs boson. It was the final piece needed to complete the standard model of particle physics, apparently solidifying our understanding of how matter acquires mass. But the measured mass of that particle revealed a troubling possibility. The math indicates that our universe is not in a permanently stable state, but a metastable one. This state is known as a false vacuum. Imagine a ball resting in a shallow groove on the side of a steep hill. For billions of years, it appears stable. It keeps our physical laws and the strengths of the fundamental forces in place. But if a random quantum event nudges that ball out of its groove, it rolls to the bottom of the hill. This would trigger a bubble of true vacuum that radiates outward, inside of which the laws of physics are irreversibly rewritten. The very atoms that make up our world could not exist in this new state. This bubble of new physics expands in all directions at the speed of light. Because the destruction moves at the cosmic speed limit, no light or signal of any kind could ever arrive to warn us. A vacuum decay event may have already begun in a distant galaxy. This sphere of annihilated physics could be racing toward us right now, and its arrival would be simultaneous with our first moment of observation. Our ultimate fate remains tied to the mystery of dark energy. In 2024, data from the Dark Energy Spectroscopic Instrument suggested that this force is not a static constant. Its density appears to be changing, potentially strengthening over cosmic time. If dark energy continues to intensify, it leads to a scenario called the Big Rip. In this timeline, the expansion of space accelerates until it overpowers every other force in nature. The destruction follows a predictable cascade. Millions of years before the end, gravity fails to hold galaxy clusters together. Eventually, solar systems are pulled apart, and planets are stripped away from their stars. In the final fraction of a second, the expansion of space becomes stronger than the forces holding atoms together. Electrons are stripped away from their nuclei. Matter itself ceases to exist, leaving only a sparse, infinite fog of subatomic particles. 68% of our universe is composed of an unexplainable force that determines the fate of every atom in existence. We are living within the consequences of a force we cannot name, which has already calibrated the silent and perfect unmaking of the universe.